Hello world, how's it going? Welcome back to my channel. Had to flip my locks real quick because after tomorrow it's gonna be a long time before I can ever do that again. So as I've been telling y'all, tomorrow's a big day. Oh man, I am excited, but also nervous, but also scared. Got a lot of emotions going on right now. Someone told me hair holds energy, and this is going to be getting rid of 12 or 13 plus years of a lot of different energy in this hair. In that time I've had kids, I've been married, I've been divorced, had relationships, I've had non-relationships. I worked as a government contractor. I've graduated college. I've started a PhD position. There's a lot of energy that's been going on in them last years. Not all good, not all bad, but definitely not all good. So this is gonna be a release and a fresh start and a starting over. So it's a lot of thought that went into this. There's been a lot of coaxing from a lot of people. Well, from one person in particular. There's been a lot of pushback from some people as well when I first mentioned it. So I kind of haven't mentioned it again. I'm just gonna do it because at the end of the day, this is for me. This has got to be for me, not anybody else. So I told you before some of the reasons why I feel I need to let them go. It's what? Oh, I don't know. It's uh, anyway. Today was good, y'all. Today was good. Today I started looking through some of my FastQC files. FastQ files, which are files I got back from the sequencing core at the university that I go to. Screw it. Go to the University of Miami. So I got back some FastQ files from the University of Miami and .gzs. I tried to download just a couple of them. Well, I did. Oh, sorry. This is for an RNA-seq project I'm doing. So I am sequencing all of the RNA that is expressed at a certain given time, a snapshot in time of the animals I am testing. I'm working with an animal called Aplysia californica. It is a sea slug, a marine mollusk. This animal is studied particularly for its nervous system and helping scientists understand how we learn. Famous scientist, scientist who won the Nobel Prize, Eric Kandel, he won the prize using this model organism to teach the world the difference between short-term memory and long-term memory. So these animals are used for the nervous system a lot, most particularly. I'm using part of the nervous system called the buccal ganglia, which controls their feeding, basically controls their feeding, the movement of their buccal mass, their mouth opening and closing, and bringing in food. I have used a design of a protocol called Learning Food is Inedible. This protocol was invented by Saswine in his laboratory, I believe in Israel, and I have been using this this protocol to teach these animals that food is inedible. So then I took out their buccal ganglia and I did a micro dissection, getting rid of a lot of the sensory neurons and motor neurons that are not involved in the feeding circuit of the animal. And then I did a RNA-seq on the feeding circuit for animals who have been trained and animals who have been not trained in LFI to see what the gene expression differences are between the animals. So for RNA-seq, I got back around 30 million reads per sample. I have a forward read and a reverse read, so 5 to 3 prime and a 3 to 5 prime read of the RNA that is expressed at the time. I then did so I've been looking at those files. So those files are, the .gz files are around 3 gigs. When I extract those and I unzip them, it's around like 14 gigs per file. So there's no way I can put all this on my computer, but I put one reverse and one forward for an ad lib fed trained animal, and one reverse and one forward read for a ad lib fed untrained animal, just to see if I can do my goal is to do a cluster analysis. I think that's what it's called, a PCA plot, proximate cluster analysis plot, is my goal. I've been able to run the files through FastQC, and interestingly, and very much to my surprise, they all have super high scores. Their scores are around 34. If you look at the traffic light plot, which is the green, yellow, red plot that indicate how good the reads are, the different lengths of the transcript. All the transcripts that I use are coming in at 151 base pairs. They also, all the reads are phenomenal. Like, I have no reads dipping below perfect in the green, which is so surprising to me. Although probably not so much because I didn't actually produce the library. I tried really hard to produce the library. It failed. So we had the sequencing core at actually produce the library for me, and then run the sequencing, and now I got back the raw files. So I ran the files through FastQC. They look phenomenal. I'm currently learning and working on them to run them through Salmon, which is a sequence aligner. Well, what I'm reading is not so much a sequence aligner, but it gives you, it still aligns and gives you transcripts per million. And as soon as I do that, I can run it through DESeq to test DESeq2 to test for gene expression, and then I can make my PCA plot off of the DESeq output. So I'm in the process of that. I did the FastQC. That went great. I saved the results, the pictures of the results, so I can present them to my advisor on Monday. I'm learning the Salmon now, so I can do that. This is a little more complicated, but I have downloaded the manuals, so I'm reading through that and how to do it. Most of these have to be run, the Salmon has to be run through the shell. I was able to, as far as I know, I was able to use FastQC through the icon and the actual app on the computer, but through the shell is a little more difficult. That takes a little more of coding, and I'm relearning that as well, because the first time I took this stuff and I learned about this coding process was my second semester here at school, which was like 3 years ago. So I'm having to relearn all of this on my own, but it's helping me to become a better scientist. So today was great. My locks are, woo. Tomorrow's the day, y'all. I probably will see you tomorrow before I do them. In fact, I know I will. So the first time you'll see the rough cut will be on Sunday. Anyway, thank you for joining. It's been great coming over my day. Please come back tomorrow. We'll talk soon. Love, peace, happiness. Be safe out there, y'all. Talk to you later. Bye.